Aloha, Richard Halverson here, and today we are in Chapter 6, and I'd like to cover the programming assignment. So let's take a look at the programming assignment. Let's see, we are around here, message encryption. And what we're supposed to do is we're supposed to revise the encryption program of section 6.3.4 by making it so instead of just having one character, we're able to have multiple characters. And this takes advantage of the feature in or the it takes advantage of the exclusive OR instruction, which when you exclusive OR something, when you exclusive OR something with the same value twice, you get back what you started with. And so the idea here with encryption in this example is you have a key. Let's say you have a key here, and the key is capital A, capital B, capital X, MV, #7, and then it starts over again. So it's like 1, 2, 3, 4, 5, 6, 7 characters long, and you exclusive OR the plain text, which is up here. This is a plain text message. You exclusive OR that with this key, then you're going to get some garbage that you can't understand. But then you exclusive OR it again with the same key, and you get back your original plain text message. So the idea is that if two people want to communicate securely, then they just come up with a nice big long key, and then they're able to encrypt their messages, send them along, send them over the internet or whatever, and then when the receiver gets it, the receiver's got the same key and is able to decrypt the message. So, and if we look in the textbook, so so here let's see where this is in the textbook, if I can remember where it's in section. Oh, it told me. Section 6.3.4. So if I go to section, let me pop this open, 6.3.4. Here, the encryption program. All right. So let me make this a little bit bigger. And so here we see that the XOR instruction has an interesting property where if you exclusive OR, this is you take X, exclusive OR Y, and then you exclusive OR with Y again, you get back X. And so here's a program which actually performs this encryption, but it just uses one character. It's a single character encryption key. The user enters plain text and uses a single character key to encrypt, and you see that it you read in, like right down here, it says bank account number something, and then when it's encrypted, it looks like that. But then you do the same. Operation again, and you get back your original text. And so here's a program, and looks like the key is 239, whatever that is in whatever that is in binary, I guess. And it reads in. Okay, so let's see what the slides. Okay, it reads it in, translates it, displays out the encrypted message, and displays out the encrypted message, translates again, and displays out the plain text message, the decrypted message. And it's going to use a function called procedure called input to string, a procedure called translate buffer, and a procedure called display method. And those procedures are down here. Let's look at what the slides say on this. So we have this key value the buffer is going to be here. The size of the buffer is simply what buff max is this. And so you're able to read it, I guess. And then, so we move the loop counter into the ECX register. We start with the beginning of the buffer, and we exclusive OR the key with the contents of the buffer pointed to by ESI. And then we increment ESI, and we go back and we do it again. Each time we do it again, we are decrementing ECX. And so it's going to go from the buffer size down to 0. When it hits 0, it's done. And that's it. So let's start with the, okay, so let's go back to here. I'm going to download that starting project, save it on the desktop. And I have already set up the Irvine library. I think I mentioned that to you before, where I put it down in my C drive right down here. Okay, and it turns out that you can install it. You can install it using this installer, which I have right here in resources. This installer here, you can download this installer, put it on your desktop, and execute it, and it actually sets it all up for you, and you never have a problem. At least I haven't yet had a problem with my programs being able to find that Irvine32.inc file. So anyway, so that's already been installed for me, and it installs this what's on the zip file here, and I do have a unzipped version of it here, and the reason I have that is well, actually, you can just get it from here. I'm down here in my C drive, down in examples. We are in chapter 6 down here, and it's this encrypt. Okay, so I'm going to move a copy of this encrypt onto my desktop. Let me control, so it's a copy. And so now I have that here. And so let's open it up. I'm going to open it up with this. And here it is. Here's our program, just like it is in the book. So let's start with this. Let's start by getting this thing running. Here's the input string. Here's the display message. It's using these Irvine 32 calls. Here's read string that reads it from the console. It's using this Irvine 32 library here. So let me open up this project 32 here. Let me unzip it. And here we are. Let me open this up and run it, see what happens. This is the add to program. Okay, here we are, and let's open this up. So here it is, this simple program. Let's see if we're able to build this thing. Any problems? Okay, succeeded, fine. Let me try to put include Irvine32.inc. we should be able to, because the default for the project properties, linker, it links to the Irvine directory already. That's got all the that's got the library, and it's got all those files that we need. Got this file, and so let's see if this will build. And it builds fine. I think there must be a dot model in there, so we can actually, I think, can we do this? Comment this out and see if we get a clean build. Yeah, it looks good. Succeeded. Okay, so everything works. So I'm going to replace this. I'm going to rename this. Rename encryption. I'll just name the encryption. What the heck? All right. So and then I'm going to go over here. Go over to my. Didn't I open that up? Go back to here. Right click. Open it up. And take this. This is the encryption program. I'm going to copy it all. Copy. Copy. And paste it. Right. I'm going to replace all this. Paste. Okay. So this is the encryption program with the key of 239. And let's see if we get a clean build. Ah, succeeded. Okay, that's great. So let's run this and see what it looks like. Let's just run it. Debug, start debugging. And this thing pops up. Never mind. Okay, enter the plain text. Now is the time for all good people. Enter. And the ciphertext looks like this. And when we exclusive OR it again, we get back what we started with. All right, so so it looks like that works. So what I'm going to do now is, for this assignment, I need to make it so instead of a key, there is a string. So this is where the the plain text string is entered. And so I need to have a second one for the actual key. So key will actually be an array. Okay, so I'm going to input the string, and then I will need to input the key string, and then the rest of this can be the same. So and so let me all right, let's just so I'm going to take this and I'm going to mess with this and try to evolve this to the new program. Never mind. So let's go. Okay, so buff max is 128. Well, let's make a key max, because so I'm going to read in a buffer, read in the plain text into a buffer. I'm calling it buffer, and then I'm going to also do exactly the same thing to read in the text, and then down. So this reads in the buffer, reads into the buffer. This displays out a message. Displays out either one, because EDX is pointing to the message, to the thing to display out. And this is the translate. This is where it's translated. And you see that this is the loop right here, where we exclusive OR each character of the buffer with the key, and we leave it there. So what we want to do is, instead of, so this loops from the beginning of the buffer to the end of the buffer, we want to also have another loop inside here where, or someplace, I guess it's, where we're looping through the key. So it's not just going to be this constant value anymore. It's going to be, we're going to be looping through just like we loop through the buffer. Now, the looping through of the key is going to be a different loop. It's going to be a different sized loop. So we're going to have to keep track of that. Sort of, we have to be kind of clever keeping track of that. So well, let's see how this works out. All right, so I'm going to start. I'm going to leave that there. I'm going to first of all, I'm going to make it be able to read in the plain read in the key. So I'm going to add another max here, and it's going to be, I'm going to call it key max, and might as well make it the same size, even though it's going to probably be smaller. Maximum key size, and that's great. Enter the plain text. This is the prompt. I'm going to have to add another prompt here because I got to add one for the key. I think I'm going to name it SK prompt. Enter the encryption key. And then this can be fine. This can be fine. Buffer. Oh, I want a key string. That's for the buffer. Okay, you got to have one for the key string now. So let's call it key string. And that's going to be a byte. And it's going to be a byte that is as big as key max plus 1, looks like. I'm just copying this up here. Space dupe 0. Dupe 0. And it looks like I need a key size. D word question mark. Okay, because I'm going to store that in there. All right. All right, and then I'm going to go down here and start out. First, we input this. Okay, we input this, and oh, we got to input the key string. Call. Oh no, I got to make a new. I got to make a new input key. This is a function here. Make sure that I'm. Let's see. I just want to make sure that I'm. Okay, I am. I just want to make sure I'm recording. I oftentimes forget that. Okay, so I've got input the string, and so I got to make a call input key. Input the key. Input the key. And so let's make an input the string. It'll be just like that. So we're input the string here. Let's do let's copy this. Copy. Paste. Okay, I got to input this. Okay, input the key. How about input the key? Input the key. Input the. How's that? Input the key. And it's going to say prompts the user for the encryption key string, saves the string and its length, nothing, nothing. Push ADS key. Write, because it's, we want to do the other prompt. Write string. Oh, key max. Offset key string. Call read string. This is a Irvine 32 library function. Key size. All right, input this. Okay, input, this has got to be input the key. This has got to end input the key. Okay, so that'll probably work. Put it in the other place. I'm just gonna see if this works. So let me see if I get a clean build. Failed. Undefined symbol. Key string on line 69. What did I call it? Keyster. Ah, maybe call it keyster. Now, how does it build? Okay, succeeded. Okay, now let's run this and enter the plain text. I want to put in I'm going to hold on. I want to put a breakpoint in here because I want to stop it and see. I'm going to put the breakpoint right here. So first I want to see that both of these come in correctly. So let me do, I'm already built it. So start debug. Okay, now is the time, and the encryption key is blah, blah, just blah. How's that? Enter, and now we're at this breakpoint here. We're paused there, and so let me see. What have I got here? I got nothing. Okay, let's take a look at some registers. And here's some registers, and I'm curious about let's see, we just ended input key, and that would be, so we should be able to see what is EDX. What is EDX? Okay, let's open up some memory here. And EDX, I'm gonna grab this value and put it up here and press enter, and I get EDX, and we should be close to something. Let's see. We can look at the debug window disassembly, and we can look here and see. Can I figure out where are these? Oh, I can look at disassembly. Where are these memory locations? Some memory locations around someplace. Where are they? This is buffs. Let's see. Displays. Prompts for the encryption string. So it's going to load offset of kprompt, which is this address here, I guess. It's this address, I guess. Can I just drag this over there now? And here we go. Blah, here's the encryption string, and here is my buffer. Buffer starts must be like right here, 4060 or 061 or something. And here's my prompts. This is a prompt and this is a prompt. Okay, anyway, it seems to be working fine. Let's stop this. Okay, so it looks like it reads everything in properly. So and I've added the input the key code. I guess now all I got to do is go down here and modify the translate buffer program. So instead of just exclusive ORing it with a single value, we have a loop. We have an additional loop here, which loops through the key string. So let's see. To do that, I think I'll use I need an ESI. The ESI loops through the buffer, loops through the plain text. I'm going to need something to loop through the key, so I'm going to use EDI, move EDI, comma 0, and this will be index 0 in encryption key string. And let's see, instead of exclusive ORing this key, immediate key constant value with buffer ESI, I want to grab the encryption key, grab an encryption key byte and exclusive OR it with that. So I'm going to go down here and I'm going to say move into the AL register key string, not ESI but EDI. Okay, so that's going to put, so this gets a key byte. Okay, and then we're going to exclusive or not key with AL. Oops, AL. Lower A register. So this AL gets exclusive ORed with this buffer byte instead of what was there was a key. All right, and then so this increments ESI, and then we loop. Now we need to increment EDI also. So let's put that in there. Inc EDI, and this is going to be point to the next key byte. And then I got to compare if we're at the top. The key sizes, we're only going to go up to key size we're only going to go from EDI up to key size, whatever that is, that's 4. And if it gets to key size, we have to zero it back out again. So let's do a compare. Compare EDI with key size. And it is, we're asking, is the key index, is it still less than key size? And if it's if EDI is okay, we've incremented EDI. If EDI is still below the key size, if EDI is still less than key size, in other words, if the value for EDI is still below the value for key size, J below, I'm going to go to L2. L2, and L2 is going to just go back to L1. Okay, I could actually, no, I need to do this loop L1 because I need to decrement this. And this loop L1 decrements ECX. So okay, and the reason I'm jumping around is because if EDI is the same after incrementing, if EDI equals key size, then we want to zero out key, move EDI, comma 0. So EDI has reached key size, so 0 it out. Okay, and then it jumps back to L1. So this is where we increment EDI. We test to see if we're done. If we're done, then we test to see if we're not done. If we're not done, we want to jump over the zeroing of EDI. We just want to leave EDI alone and go back to the loop. But if we should happen to increment EDI and it increments and it ends up being the same size as key size, then we need to zero it. So we will not take this jump. I'm going to say, is key index less than key size? Yes. Index is less than key size. So jump over zeroing of index. So that jumps over the zeroing of index, which is moving 0 into EDI. All right, so this might be pretty good. Let's see what this looks like. I have a so right here we're going to see that we're going to call the translating of the buffer. Let's this is just going to display it out. Let's pause there, and we're going to translate the buffer again, and this is just going to display it out. So let's we will stop, and we will see the input string there, and we'll see the key there, and then we hit a breakpoint. Then we go, and we're going to do the translation, and we're display it out, and then we're going to wait because I want to go and look and see that this buffer now contains encrypted values, and then we're going to continue on, and it'll do the translation again and display out the original value again, and we should be able to look in here, and we should look in here, and we should see the original string again. So let's build this. Hope it builds. Very good, succeeded. And let's go hit debug. So now is the time for all good people to come to the aid of their party. Period. Secret string. Okay, now we've paused, and we paused right here, so we should see the input string, which is now is the time for all good people to come to the aid of their party. And then we see this is the secret search string right here. Secret string. Okay. Now I'm going to hit continue, and we should see, when we hit continue, we should see the encrypted string pop out here. But then we should also see that this is the encrypted string. This becomes the encrypted string. And so let's do that. I'm going to continue. Let's put this up here. I'm going to continue. I wish this thing would just relax and not bother me. Okay, so the ciphertext came out, and it looks all garbagey. It's hit some returns in there, and there's got to be a better way to display out the ciphertext. I know of a better way, but let's just stick with this right now. Anyway, let's look in here, and we should see here's the encrypted. This is what the encrypted data looks like. See, it's red, which means it just changed. So this is all garbagey, garbage. See, there's a bunch of characters in here that aren't displayable. Look, there's even a 0 in here. All right, so that's fine. And so now we're down here, and we're at this breakpoint. And now when I go again, we should see the original text reappear here. So it goes all the way to there. Okay, and we should also see it. We should see the original text pop up here. So I'm going to click continue and look at that. This came back. Now is the time for all good people to come to the party. We're down here now, and it did come out here. Now it's time for all the people. Okay. All right, so that looks like that's it. I think we're done. I can just continue, and we're done. And so that pretty much takes care of the assignment. So you want to make sure that you take a screenshot of your program pause just after exiting, just before exiting, like the last thing I showed you. And you want to show some registers resulting array. And that should be it. So you would want to you probably want to put these breakpoints in the way they are, and just run this again. And hello world, and I'm going to just do A B. Let's see what that does. And it stops there, and we see that. Oh, we see that hello world and AB, and then let's run this again, and we see the decrypted text looks like that. Looks like that. And then we're going to run it one more time. And we see the thing is back like that. And let's put this up here. And let's see. What am I asking for again? Pause just before exiting, showing both your program registers and resulting array. All right, so do something like this, where we got this up here, and we got some registers here. We got some memory here, and I don't know. Maybe put this over here or something. Well, put this over here. This window over here, maybe like this or something. Who knows? And take a screenshot of that. Pull up your screenshot deal, new, and grab this thing and submit this. So I don't need this. Okay, well, I hope that that should finish. You should be able to do your next assignment now, and I hope you understand. You've learned about conditionals and how to do these jumps, and how sometimes it seems like you're doing things the hard way in assembly language, but you're at such a basic level. And now you can also start seeing how compilers, the job of a compiler. The job of a compiler is taking your higher level expressions and translating them down to these, very basic operations that the processor is able to execute. So we still have to finish the rest of chapter 6. I will cover that in the next video. Thanks for watching.